a garden or a forest floor or a crack in a city pavement, millions of small creatures are at work. They have no manager. No one is giving orders. No single ant has ever looked at the colony and thought, "This is what we need." And yet the colony thinks. It solves problems. It makes decisions that no individual ant could make alone. That is the thing worth settling into tonight. Not the ants themselves exactly, but what they suggest about minds, about how intelligence can live not inside one creature, but between many, how something that feels like thinking can emerge from the quiet sum of tiny, unhurried actions, each one meaningless on its own, each one, somehow, part of something vast. Let that idea rest gently at the edge of your awareness. You don't need to hold it tightly. Just let it be there, like a lamp in the distance. The word scientists use is emergence. It refers to the way complex behavior rises up from the simple pieces, the way a wave is made of water molecules that have no idea they are making a wave. A single ant has a brain roughly the size of a grain of salt. It cannot plan. It cannot reason in any way that resembles what you do when you solve a problem. It follows chemical signals called pheromones, responds to a small set of cues, and does whatever its role requires. Forager, soldier, nurse. The ant does not choose. It simply is. And yet, place 100,000 of these simple creatures together, and something changes. Something slow and patient and rather beautiful begins to happen. The colony finds the shortest path to food. It manages its waste, keeping dead ants in a specific corner of the nest, far from the living. It regulates the temperature of its chambers by opening and closing tunnels like a living thermostat. If one part of the nest is damaged, the colony reorganizes without being told, without panic, without any individual ant understanding the full picture. There is something interesting in the fact that it took humanity a very long time to understand how this was possible. For a long while, people assumed there must be a queen giving orders. The queen ant seemed the obvious candidate. She sits at the center. She is different from the others. She must, surely, be in charge. She is not. The queen's only role is reproduction. She lays the eggs. That is her function, and it is vital. But it is not leadership in any sense we would recognize. She issues no commands. She has no more awareness of the colony's needs than the smallest worker at the outermost tunnel. The queen does not know she is queen. Breathe. What researchers eventually understood, through patient observation across many decades, is that colonies run on something far stranger and more elegant than command. They run on what is sometimes called stigmergy, a wonderful word. It simply means that each ant responds not to instructions, but to the state of the environment around it. An ant leaves a pheromone trail when it finds food. Another ant detects that trail and follows it, reinforcing it with its own pheromones. More ants come. The trail grows stronger. Over time, if two possible routes exist to the same food source, the shorter one will almost always win, because ants returning via the shorter path arrive back sooner, and so they reinforce that trail more frequently. The colony has, in a very real sense, solved a mathematical problem, not through cleverness, through repetition and chemistry and the quiet accumulation of small choices. Biologist E.O. Wilson, who spent much of his life among ants and eventually won a Pulitzer Prize writing about the social lives of creatures, described colonies as superorganisms. The individual ant, he suggested, is less like an animal and more like a cell. The colony is the creature. The colony is the one that eats, breathes, defends itself, grows, and dies. There is something almost meditative about that idea, that you might look at what seems like a crowd of individuals and see, if you soften your eyes a little, a single patient thing. We continue softly. One of the quieter and more remarkable findings in the study of ant colonies comes from their response to stress. When a colony faces a shortage of resources, foraging patterns change, but not in the way you might expect. Ants do not simply work harder, running faster, sending more scouts into the world. Instead, the colony shifts in a more subtle way. Individual ants become more selective. They respond less often to weak pheromone signals and hold out for stronger ones. The threshold for action rises. This is not a decision made anywhere. There is no committee. No ant has called a meeting. And yet the collective behavior recalibrates, as though the colony itself has taken a breath and said, "Let us be more careful now." Some researchers describe this as distributed cognition. The idea that what we call thinking does not have to happen in one place. That cognition, the ability to weigh information and arrive at a useful response, can be spread across many nodes, each one doing something small, each one contributing to something larger. You may have drifted. That's fine. It is worth lingering here. very gently on what this means, because there is something in it that goes beyond ants. The ant colony is not a metaphor. Exactly. It is a real and remarkable thing. But it does gesture toward a question that has quietly occupied scientists and philosophers alike. What is the smallest unit that can think? We tend to assume the answer is the brain. Your brain. The organ behind your eyes, which is working even now. Even as sleep pulls gently at its edges. But the ant colony suggests the answer might be less tidy than that. That thinking, or something very like thinking, can emerge wherever the right conditions gather, wherever information flows and gathers and is acted upon, wherever patterns accumulate into responses. A single neuron in your brain is not so different in its basic logic from a single ant. It fires or it doesn't. It responds to inputs. It passes signals along. It knows nothing of the thought it is helping to create. And yet you, the sum of billions of those tiny events, can dream. There is something slow and gentle in that symmetry. The vast and the small, each finding its way towards something resembling wisdom. There is no rush. Perhaps the deepest thing about ant colonies, the thing worth carrying softly into sleep, is how unhurried they are. A colony can live for decades. Leafcutter ant colonies, those ancient, patient civilizations that farm fungus beneath the forest floor, have been known to persist for 20 years or more. They do not rush. They do not panic. They do not mourn what is lost. They simply continue, one small action at a time, each ant doing its small thing, the colony persisting without knowing. It persists. There is a kind of peace in that. Not the peace of having everything resolved, but the peace of simply continuing, of not needing to understand the whole in order to take the next small step. The ant doesn't know about sleep well